All right, this video is going to be on ion channels. So before we get into the nitty-gritty of the action potential, we've talked about the resting memory potential and the setup of the electrical and chemical gradients in the neuron. I want to review / extend on what you know about ion channels and the types of stimuli that can open gated ion channels. So I already reviewed, I just said some of these words already. There's two broad types of ion channels. First of all ion channels are channels. So they have just kind of open up and, or are open and have a space in between that allows ions to flow through. So Na plus, K plus, etc. Small charged ions that cannot move across the membrane without that protein there, because why? The ions are hydrophilic and the core of the plasma membrane is hydrophobic. So ion channels fall into two categories that you already know: non-gated, so just always open, and gated. So this part should be review. Non-gated are just always open. Gated, this is like a simple way of drawing this, would have some sort of gate, like that. Another word for non-gated is what? Leak, because they're leaky. They're always leaking because they're always open. It's like having a just faucet leaky, dripping. So the potassium leak channel is the one I talked about. That's really important for establishing the resting membrane potential of the cell because it is very prevalent. There are a lot of these proteins embedded in the cell membrane, and potassium can leak out of them constantly. I like this image just because it kind of shows the importance of this selectivity filter. So the idea that only potassium can go through this channel. So these ion channels are specific to certain ions. Some are more specific than others. So there'll be some that allow different types of charged particles through. A potassium channel is just going to allow potassium through. This also shows the three-dimensional structure of the protein with alpha helices that you don't need to know about, but good to remember that our proteins are not just blobs, like I will draw them. So leak channel should be review. What I want to go into a little bit is this: what stimuli can open a gated channel? So what types of gated channels are there? Because that's going to be super important for the action potential, as well as a lot of other stuff this semester. So there are three types of gated ion channels. So think about, if you just even brainstorm, right? If you're going to have a gate, what can open a gate? You can push on it, right? So that's a mechanical stimulus. That's going to be the last one I get to. So the three types are chemically gated. This is a ligand is a chemical. A ligand is the name of a thing that can bind. So that thing would be some chemical messenger, for example. So there's some gated ion channels that open up when a chemical or a ligand binds to the protein, changes the protein's shape. Then all of these gated ion channels, it's based in a change in conformation of the protein that changes its function, meaning the function that changes is it opens or closes again. Third type is voltage gated. So a change in voltage or electricity. So voltage is measured in millivolts, right? So the amount of negative or positive inside the cell compared to the outside of the cell can open up gated ion channels. And lastly, we've got our mechanically gated. These is the push. So a push will open a channel. It's a physical change due to pressure. I'm going to briefly talk about these three, and we'll see them again in context in the future. So the first one is the chemically gated or ligand gated, same thing. The example here is acetylcholine. So this protein, it's gated, it's closed right now. When this acetylcholine, it's a chemical messenger. Acetylcholine is actually important for neuromuscular junctions, so muscle firing and muscles contracting. When acetylcholine binds to this protein, that causes the channel to open. When the channel opens, positive ions can go inside the cell. This is both calcium and sodium. So acetylcholine binds, opens the protein, period. Once it's open, ions move down their concentration gradients. Okay, we'll talk more about different types of chemicals other than ACH when we talk about synaptic transmission. So neurotransmitters are chemical messengers. Number 2, voltage-gated ion channels. This again is a change in the negative or positivity of the inside of the cell. So remember, at rest, this would be at rest, the cell is at negative 70 millivolts inside the cell compared to outside of the cell. In that, this protein shown here is closed. There's a gate and it's closed at that voltage. When the voltage changes, when it gets more positive inside the cell compared to the outside of the cell, so minus 60 now, that is more positive, but the change in voltage, the channel opens. Voltage gated. When the cell becomes even more positive inside, it closes again. This special channel we'll come back to with the action potential. The point for now is a change in voltage changes whether the channel is open or not. And that is going to allow certain ions in. That certain ions, just want to show you here, this is just showing you there's different channels for each type of ion. There's voltage-gated sodium channels, voltage-gated calcium channels, voltage-gated potassium channels, etc. Lastly, mechanically gated ion channels. This would be an example for like touch receptors in your skin, where it's actual physical distortion of the plasma membrane causes the protein to open, the channel to open. So pressure applied or removed. This is also important for hearing, actually. So this is another way that gated ion channels can open. Okay, so what we've done here is list the major ion channels of neurons and describe them as leak or voltage gated, mechanically gated, or ligand gated. The second part here, identify where they are on the neuron. This I want to draw for you right now. So I want to draw for you a neuron, and I'm going to tell you where these different ion channels are located on the neuron. Then we'll, in future lectures, come back to using these ion channels, what's the importance of these. For now, I just want to give you an overview of where they are. So there is our cell that you know so well, our neuron. This whole location here, so the dendrites and cell body, this is going to have either ligand gated or mechanically. Let's move me out of the way some more. It's just get me nice and small here. Or mechanically gated. These two types are present on the cell body and dendrites. Now, along the axon itself, there's going to be voltage gated ion channels. And I'll be more specific here. This is going to be K plus and Na plus. That's all along the axon. Lastly, we've got the axon terminals. Axon terminals, here there are voltage gated channels, voltage gated calcium channels, 2 plus, I'm putting in. So we'll come back to this, these locations of these different ion channels, when we talk about the action potential real soon.